12 cores, 64-bit performance, AI accelerator, 250 grams of weight, and 2 5 gigabit Ethernet ports. Shenzhen Xunlong has shown the industry once again where the human meat is bought. And if you want to find out more about what this machine can do, please stay tuned, because I've got a sample right here for you. Here we've got the box of the OrangePi 6 Plus. For comparison reason, a Raspberry Pi. You see, this is a very large box. We open it some more, and then we see in here, this is like the money shot for the out-of-box experience. We see, first of all, some mounting screws, and then the actual process computer, which is this guy here, and then below there is the rest of the packaging material. So to resume the unboxing, here we have the machine, and here we see the bag is sealed, so we have to cut into it. And here we have the machine. This is probably the biggest single board computer I've ever reviewed. On the top we have this absolutely massive heatsink. Here we've got the combined Ethernet and USB 3 ports. Here we've got some HDMI interfaces, power interfaces, and then just a wide variety of other ports for fans, a headphone jack, and so on. And when we turn the thing around, the madness just continues. We've got a total of 3 slots which provide expansion for peripheral devices. Why they are valuable, we will look at shortly. And then we've got these camera interfaces here, and here of course the slot for the micro SD card, which is intended to start up the machine. And for a little size comparison, the number 6 here, the number 5 here, and it is just purely obvious how the number 6 just dwarfs its predecessor. And incidentally, this is a display port and an HDMI port here in the front, one of each. But it's clear, you see, this is just a much bigger machine, much beefier, much heavier, and you see the huge heatsink. And also what you see is that the whole GPIO interface complement, except for the headphones, is on one side, whereas here on the previous model, you had 2 different sides for the things. So it's more easy to use this also as a desktop replacement of some sorts. And when we compare it to the Raspberry Pi, whether it's a 5 or a 6 or a 4, 5 or a 3 or a 4, it doesn't matter. You just see a completely different class. But this is a completely different machine, of course, it's completely different performance levels, as we will find out very shortly. Because our precision scale is paid off, let's start off by measuring a little bit. And we see 100 is too much. 200, it's over 200. Particularly as we see here, it's approximately 253.41 grams for the new machine. And now we are going to take one of the older ones. No, I'm not removing the memory card. Here we have approximately, as we see here, 86.89 grams for the OrangePi 5. And finally, for the Raspberry Pi 5, we have 46.45 grams. These two have the memory card inside, so it's minimally less. But it's obvious this is the biggest process computer we ever had in the lab. And here we see the board in a stripped state. We have here HDMI 1.4, DisplayPort 1.4. We've got an USB 2 pin socket, which simplifies integration. Then we've got a battery interface here. Yes, this is the main processor, which we of course cannot see. A tiny little flash ROM. And then, yeah, here we've got the audio chip. We've got an analog microphone input, speaker input, an RTC input. It's just the usual equipment that we know, basically, with of course some additional interfaces, making it more pleasurable to use. Yes, here in the back, we also see basically what we expect. USB 2 here, USB 3 below, USB-C over there. And then finally, here at the bottom, we see we've got an EDP display interface here in the back. We've got the two 5G Ethernet chips, which we mentioned, and we've got the 3 SSD slots. 2 for an NVMe SSD and 1 for an M2 E-key. So this is where you will install a Wi-Fi or a Bluetooth card to add wireless peripherals to the process computer. You don't like to see it, I don't like to do it, but it needs to be done. Down here, like, subscribe, and activate the ring, ding, 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 ding. Incidentally, once again, this here are the two 5 gigabit Ethernet chips, and these are made by Realtek. It's a bit difficult to see in the video, but it is an Realtek RTL 8126 here and here at the bottom. This here is deserving of a special mention because this is a 9-pin header for USB 2.0. And you see, it complements this thing here, and it can be very useful, for example, when it comes to connecting an external USB device of some sort or another in an embedded application. You see here, it's a classic click-fit micro SD slot. And this means that the system is just more vibrationally robust in everyday usage. And as for the actual bring up, you've got these 4 little feet, just in case to add some spacing. And you see they go into this hole, and the 2 holes in the back. It's pretty simple. It's just a construction like this. You see them here, and you just screw it in like so, basically. It's not particularly difficult to do. For the operating system, we go here. We click the download tab and we find again Debian, Android and the OrangePi OS. There is also a Windows image, but I cannot access it at the moment. And here again we see the various versions of Bookworm with different kernels. And as for Android, we see it's based on Android 14. But we, of course, will be going for the latest Debian Bookworm. We download it, and then as usual, Google will cry, and the rest of the drill, well, you know what to do. And here I just have to mention something and give a shout out to this little thing here. It's an amazingly cheap card reader. It costs like $2 or something, and it's USB 3 capable, and it just makes deploying these images so much faster. So if you are a process computer jockey like me and you're looking for a Christmas present for yourself, buy one of these. I've got the link in the show notes. You will definitely not regret it. And now it's time for bring up. What's important? The blue lamp means nothing. You need to start the machine by pushing this button here, as you saw before. Then you get this green blinking here. Only push it once. And then if you have a studio monitor, within a few seconds, you will see the screen wake up and the boot up process start. And then you get the usual check for video cable for a few seconds. And after that, the actual startup process commences. And what's important to keep in mind here is that the fan does not spin up at this stage in the procedures, at least not usually. And then after a bit of time, you get this desktop which you see here. And yes, the fan will be spinning on the board a little bit. In the settings application, you find here the SSH client, which on my system is activated by default. Well, now how to find the OrangePi? I like to use nmap. Here you see the command. This is the IP range. This is the usual, the net mask. And then here we already have our OrangePi. This is his IP. So now we can go SSH. And in we are. The password is also OrangePi. This is kind of unsafe, but well. And here we have it. Now it's usually the time for the apt upgrade. You know this already, the drift. And incidentally, you will hear the fan, even when it is in the standby. You will hear the fan work a little bit. Here we say yes, started automatically. And while the fan is audible, it is not particularly annoying. It's about as loud as my silent AMD workstation. So it's not gonna be disturbing you a lot, but of course it's not a fanless machine either. And now comes what always comes. We need to install SysBench. And it's already time to run our usual test. So, first SysBench run is with one thread. And we get 3000 events per second, and we'll run it again. And it's again about 3000. And again about 3000. And the reason why I'm playing around with it so much is because we see this structure here on the SoC. We've got 4 super high performance cores, 4 smaller cores, and 4 economy cores. And the scheduling on such a complex system can always be an interesting task. So, the next etape is 4 threads. We get this, so it seems to scale up more or less linearly. Now we go for 8. And we see it doesn't quite double. We've had here about 12,000 and now we've got 22,000. So the 4 additional cores are still quite powerful, but not quite as powerful as the first 4. And now we go for the maximum, which is the 12. And we see we don't really get all that much. So the last 4 are approximately as powerful as one of the super large cores was. And yes, this is by and large where we would expect it to be. Next, it's time for my traditional torture test. This time we will need a total of 12 threads. And before we run it, we need our trusty thermal camera from Infiray. And now it's time to push enter and start the camera. And now you know the drill. We'll remove the keyboard a little bit to get us a better view. The fan is still running at its normal speed. And now it started to run faster. Now it's clearly audible, approximately like an IBM ThinkPad T430 or so. But we see that the system's performance itself still is pretty well in check by and large. And now we are 2 minutes into the test and we see temperatures have not increased too much. So by and large, the cooling system is very well able to deal with the power caused by SysBench. By default, the machine starts only when you push the power button. You can work around it via entering the BIOS. For this, we go into cold and dark, remove all memory, hold this button, push this button to start the process, and then we immediately start to mash the F2 button and release the boot button after a bit of time. And then when you are done mashing the button, when you stop mashing it, eventually you see the BIOS show up as shown here. And what is interesting is that this process computer actually has a BIOS. And when we go here into the CIX system manager and into the platform configuration, then here we can say that the system should power on again when it is unplugged and replugged. So you don't need to push the power button to start the system. But the problem with this is that saving the configuration requires the presence of an RTC battery, because the BIOS parameters on this machine are not stored in flash but in the RTC memory. So the next test is involving GPIO read all. And we see that there currently is no support, or at least no native support, for the GPIO library. So, next step, let's get ourselves this. Then we start the build process. And we kick off the build. So, it needs sudo. And now we've got it working, or so it claims. So let's try again. And we see here, oops, unable to determine the board type. And if we go here into the official source code, we see that there is something for the 4A and for all the 5s, but as of now, this has not been updated for the 6. So as of now, as of today, the 15th of November, there does not seem to be wiring GPIO support for this new system. And with that, I thank you for your attention. As always, any questions down here, and I'm always willing to try and answer them if I can. Bye bye.